So my name is Tom Lefebvre. It's a French name. The B is silent. It actually means I'm a French ironsmith. And for 30 years, that's what I've been doing, working in manufacturing with iron and steel companies that manufacture products made out of steel. I'm a product cost manager for Goodfield, which is our tillage platform. If those of you that are in Illinois, it's between Caterpillar and Bloomington on 74. And it was started by a high school student that somebody taught him how to weld, and he started fixing tillage equipment, and all the people said, "Fix mine, fix mine, fix mine." So he started a company. And his idea of product development was put a brick wall in the dirt, get the biggest tractor with the biggest horsepower, put your equipment on it, and run it into the wall and see what breaks. So it might be crude, but he developed it into a multi-million-dollar company. Got too big for him, and he sold it to the employees. That's when I started there as a manufacturing engineer. It was employee-owned, and then Case bought us. But when Case bought us, I had left for a job with Case in Moline making combines. But anyway, it advanced my career moving around the Midwest. I've worked at Lennox Manufacturing in Marshalltown as an advanced manufacturing engineer. So I actually started my career as a machinist at Caterpillar, and Caterpillar paid for my degree in industrial engineering from Bradley University in Peoria. And then the company that was employee-owned, what used to be called DMI, Design Manufactured with Ingenuity, and they paid for my master's degree from Bradley University. So I have a good background in manufacturing. Like I said, I'm at Goodfield, Illinois, but in the last year, the company has acquired 2 more plants, Overum in Sweden and Kutno in Poland. And so my responsibilities have been stretched hugely. And I mean, I see this tool as probably getting the most out of the resources. There's not a company you can go to and talk to that they're going to tell you that's the issue with all development projects, is there's limited resources. And so I need to correct, we've only had this pilot kicked off like 5 months ago. And 2 months, really, we were just learning the tool, trying to get the engineers engaged to use the tool. And so 2 engineers, they're fully engaged with the software. And these last month and a half, I mean, they've been pouring out the work. So we've identified a lot of opportunities. We have another engineer that actually what he's doing is he's doing quality improvements, and he's designing opportunity A, opportunity B, and it allows him to make some cost comparisons and actually flags you for some mistakes. If your leg length is too short, or if your pocket is too small to get into the machine, it'll identify the design engineer right there in the design that there's a problem. And so he gets automatic feedback not only for cost, but for issues with manufacturing. The advantage we have is that before he'd have to do his design, and then if you know engineers, they're going to choose the most robust design. And the most robust design usually has the largest cost. But to an engineer, that's really what his focus is. I don't want any issues with my design, so if it's over-designed, better for me. But this allows them to get cost feedback and become more cost-sensitive. So that's a great communication tool to help them to be more cost sensitive to the cost of what their designs are. Most of my career I've been telling engineers on drawings, use functional tolerances. If this is a hole to hang on a paint line, don't put plus or minus 10,000 on the hole size and geometric tolerancing on the whole location, because it's going to add cost. And if it's not to your print, then we're going to pull all the parts and hold them and maybe even scrap them out, and it's a hole for to hang it on the paint line. So design engineers, they're touching the product first. And that's where the opportunity is to make the most cost benefits, is right at the design phase. So in our process, it's a long process. He designs it. He picks his most robust design. He goes and has to get prints. He has to get DFX files for manufacturing. And he has to try to get manufacturing involved in the design. And that's where the issue comes. Manufacturing, their problem is putting out fires for production, issues on the floor. So getting their resource of manufacturing to interact with design engineer has been difficult. This is basically 2 months of what we identified for cost reductions. The first one is a turnbuckle, which I'll show you where it's located on the machine. And for you that don't know what tillage does, tillage basically tears up all the ground, helps with the residue management, allows air and water to get down, the roots to get a good structure so the plants can thrive and you can get more corn per acre or soybean per acre. And the other one was a roller, and those have been implemented. This list has probably got, I don't know, 20 more projects I could add to it, and it's 2 weeks old. So just those projects, we have a potential of $300,000 savings, and like I said, this is 2 weeks old. The first two we've implemented. The others we're still waiting for approval. So the turnbuckle is on the hitch where it attaches to the tractor, and basically it's to manually adjust the leveling of the front to back level of the machine. So if it's down too far, it allows you to crank it up and 4.5 to get it level. And almost every machine we make has one of these. And we have other machines where the wings are independent, and so on those machines, every wing has to have one plus the main frame. And so I guess that's on my left, that would be on your right, that's what our current design was. It was a welded design, probably before 10 years old or so, but high in cost. And it identified that this should be the manufacturing costs, where our cost was a lot higher to manufacture it. So even our own design should have cost less. And during the process, we allowed manufacturing to look at it, and they said with the new design on your left, the $68 one was a streamlined design. Did I get it right? On the right? Yeah, I'm backwards. But anyway, the $68 one was a streamlined design, and we asked manufacturing if they could manufacture it. They said they could not, and so we went out looking for sources for it, and it turned out to be $100,000 on my spreadsheet, but now with putting it on other machines and other places, it's probably a lot more than that. And then the other one is it's a guide for the wing when it folds over, so that the wing doesn't rub against the other part of the machine, and guides it into place. This here is what it looks like, a washer, but there's one on each side. It was made out of 1-inch material, and it was cut on a laser, which was a very high price work center. The hole was machined, and then a bushing was pressed into it. I don't know if you can see the bottom, but the very bottom one, it was like the supplier was charging us almost $40, and we wound up on the one above it for manufacturing. If we insourced it to make it for $26 and change, we changed the tolerance on the outside OD because it was like about 5 or 10 thousand short of a standard round material. So the new process, instead of laser cut, is we take a round, we saw it to the thickness, we drill the hole, and it turns out to be a very good cost savings for us. And like I said, we've really only been 2.5 months really getting work out of the tool. So some of my observations from using aPriori at this pilot, and like I said, I've only been engaged with the pilot for 2.5 months. It quickly identifies potential savings, which is great. I mean, there are other tools that can do it. I used to do it manually, but it takes a lot of time, and this cuts down the cycle time for getting across quicker. It's very easy when you have a design to make comparisons, if you want to source it in the US, India, China. Once you have the design loaded, you can do a lot of what-ifs that there were never time for as a cost manager. And they get the immediate feedback, they can tweak their design, they can get cost out right at the design phase. And then there's more accurate, for purchase parts, is more accurate costing on what the should cost be, which would allows us to have data to go to our supplier and say, this is what the process in aPriori is, why is your cost different, and what's your process, and why are the costs. It allows you to do a lot of better negotiation with suppliers, even negotiating with the manufacturing team. With why is your cost so much higher than what the should cost is. The biggest thing I see is I'm going to have responsibility for 3 plants. And so each plant is different. And they have different cost structures, different culture. But with this VPE, virtual production environment, we can develop 3 different plants with different cost structures. So there's some things we can do, or we would love to do, if I get to use this tool full time. And the main one, like I said, is have VPEs for each plant, to customize it for each plant, to load our individual machine tools at each plant. And that way, they have costs that matches what their processes are. On sheet metal, it was very accurate. You know, when we verified against Goodfield, there was, I don't know, 4 or 5% difference in some of them, which is not bad out of the box, not tweaked for Goodfield. I do like the nesting feature that we got to utilize. Usually we had to get a manufacturing engineer, he had to program, get a DFX file, he had to program it, and he had to tell us what the utilization is for a sheet. And usually you didn't get any feedback saying, hey, you know, if you just trimmed 1/8 of an inch off this part, you'd get another whole row out of the sheet. Because he wasn't really concerned with the costs. He just did what he was told and gave you what the utilization is. Well, now a design engineer can look at it, and he can say, wow, I have a lot of room on the end of my sheet. Hey, if I cut my size of my part down, I can get better utilization. So I mean, in the future, what we really would like to do is tweak it for our individual factories. We'd like to share the information with the manufacturing engineer and actually get the manufacturing engineer by verifying what their cost is against what we'll get out of aPriori to show them that it's very close. And we'd like to get the manufacturing engineer on board with the costing coming out of aPriori for the different plants. And then we're all on the same page, and there's very little chances for changes late in the process. We're always developing new products, and we're always wanting to say collaborate, collaborate, collaborate. But like I said, the engineers, they're under a time schedule, and manufacturing has to take care of daily production. So getting those two groups to collaborate and communication has been very, very difficult. And that is the objective has always been of the company is the better the information is up front, the better you have your design, then the less problems there is at further down on developing a new product. If manufacturing resolves all the issues up front, then there's not, well, you know, we can't do this. You're going to have to buy it, or you're going to have to find somebody else, or you're going to have to change it. Those late changes, you know, eat up resources and make the programs run later. So the best time, really, for making a cost improvement, the best bang for your dollar, is when you're developing a new product, when he is designing the prototype. I don't know how many times I've identified a cost reduction and gone to the engineer and said, you know, hey, you've got this gigantic savings. Can't we make this change? And he'll tell me, well, I don't have enough time. Or he'll tell me, we tested this design, and you can't do that because we'd have to go back and retest. And so you're handcuffed when you're further down the design cycle to what you can really change and what you can really impact for a cost reduction. That's my, and I have a little graph. It kind of shows you that it's up front. It's in the concept and design cycle where you can really impact getting a very profitable and competitive cost for your design. Once you get past concept, it diminishes rapidly, you know, and when you into the development, there's very little, so mainly you're trying to tweak labor because the design is set and you can't make major changes to the design. So I am looking forward to getting the opportunity to work with this tool more. I was lucky that Goodfield was one of the plants that got chosen for this pilot. I've made believers out of our design engineers. They're more in tune with costs, which will make my job as a cost manager a lot easier. So I thank you guys for the opportunity, aPriori, to speak. It's been a long, long time since I did any public speaking. Like I said, I should have took some public speaking classes before I came up here. But I appreciate your patience, and I appreciate your time. Thank you very much.